Hey everybody, today we are doing our Unit 7 review solutions. Start off with some of our key vocabulary. We have solute, solvent, solution, polar, solubility, acid, base, and molarity. I would go through and I would pause the video and write down each of these key vocab words to make sure you have them all in one area in your notebook. Not going to read every definition for you. You can pause and take down those definitions that we have talked about throughout this unit. Very, very, very important for the exam coming up on Monday. Our first topic we're going to talk about is water and then concentration. So first, just some key points on water that we explored our first day in this unit. First of all, water is a polar molecule. What makes it a polar molecule is the fact that it has a partial positive charge on hydrogen and a partial negative charge on oxygen. So it has different charges on different ends of the molecule. What that allows water to do is become a universal solvent, meaning it can dissolve almost any ionic compound. The reason it can dissolve an ionic compound is because the partial charges on water attract the ions of the opposite charge, allowing water to dissolve those compounds. So if you put in salt, you have Na, which is positive, and Cl, which is negative. The hydrogen would attract the Cl, the oxygen would attract the Na, and it would cause that NaCl to break up and dissolve. So that is why water is able to dissolve ionic compounds. And polarity is what gives water its unique abilities. Concentration, a lot referring to water with solvents and solutions. An unsaturated solution, that's when there's not enough solute. So everything is going to be dissolved, but if more is added, it will continue to dissolve because it's unsaturated, it doesn't have enough yet. So if you had an unsaturated solution of sugar and water and you put in more sugar, that sugar would continue to dissolve, and that would make the original solution unsaturated. A saturated solution is generally the correct amount of solute, meaning it's a homogeneous mixture, a homogeneous solution. If anything is added to a saturated solution, though, it will not mix in. It will end up becoming supersaturated because with a saturated solution, we are at the exact perfect amount of solute. So if anything's added, it's going to make it supersaturated. A supersaturated solution is when there's going to be too much solute. They have put too much sugar in the water or too much salt in the water. So there's going to be leftover solute found floating around in the mixture or sitting at the bottom of the mixture, and no matter how much you stir it, it will not mix in. So that is a supersaturated solution. So those are our key terms with solutions. Okay, for acids and bases, these are just comparing the properties of an acid and a base. Again, I would do this review in my notebook and just have everything side by side, everything on 1 or 2 pages, so that way you can follow it more easily. Acids, they release hydrogen ions. Their H plus concentration is greater than their OH minus concentration. That is important. They taste sour. They turn litmus paper red. They have a pH of less than 7. And then if you look at the pH scale, a strong acid is a 1. So that's like hydrochloric acid or something along those lines. A really strong acid is 1. A really weak acid would be 6 because it's approaching neutral. So all of that important. H plus greater than OH minus and everything else. With bases, a base releases OH minus ions. That's also known as hydroxide. So a base releases hydroxide ions. Hydroxide concentration in a base is greater than hydrogen ion concentration. So OH minus is greater than H plus. It's just the opposite of what was over here with acids. They taste bitter. They turn litmus paper blue. They have a pH greater than 7. And then a strong base will have a pH of 14, and a weak base would have a pH of 8. So the higher you get up the scale there, the stronger the base. So you can compare acids and bases there. Again, this is something I would highly recommend you take down in your notebook. Okay, pH versus POH, or pH with POH. The equation that you always want to look at is pH plus POH equals 14, meaning if in a problem you are given POH, then you solve for pH and then determine if it's an acid or a base. So example, if in a problem you have something that has a POH of 8, what you need to do is you plug 8 into that equation. So you plug 8 in for POH and then solve for pH. So if you plug 8 in for POH, it has to add up to 14. That means the pH is 6 It's under 7, and therefore it is an acid. So we determine whether or not it is an acid or a base based on its pH. So if you are given pOH, you need to use this equation right here and solve for pH. When referencing H plus concentration, this is what's going to be the focus on the test. We won't really get in too much to OH minus concentration. So really just focus on H plus or hydrogen ion concentration. The exponent is going to tell you the pH. So this right here, the exponent, that is going to tell you the pH. So right here, with number 1 here, the pH of number 1 would be 5, because I look at the exponent, I see the exponent is -5. Therefore, the pH is 5. Therefore, it is an acid, because this number is lower than 7. I see here H plus concentration, 1.0 times 10 to the negative 12. Therefore, the pH of this is going to be 12. Therefore, it is going to be a base. Now, one question a lot of people had during the quiz that you should note is make sure if it asks which compound or element is more basic. A lot of people thought that meant neutral. More basic means has a higher pH. More acidic equals lower pH. More basic equals higher pH. So of these two, which would be more basic? It would be the second one because it has a pH of 12. Therefore, it is more basic than something with a pH of 5. So that's a key thing with H plus concentration. Just know that the exponent is telling us the pH level. So if you're asked what's more basic, it's whichever one has the highest pH. And any pH above 7 is a base. Any pH below 7 is an acid. Okay, our last one here. So molarity. Molarity equals moles divided by liters. You can use the molarity triangle. Remember the molarity triangle. For some reason the pen isn't working for me, but just remember the molarity triangle is you just draw the triangle like the density triangle and put M in the lower left-hand corner, capital M in the lower left-hand corner, moles on the top, and liters in the lower right-hand corner, and you can convert in that way. One additional note, there are 1,000 milliliters in 1 liter, so if you need to convert between 1,000 milliliters or between liters and milliliters, that's what you would do. There's 1,000 milliliters in 1 liter. So like if we look at the first one, it says given a solution with a molarity of 4.0 and a volume of 12 liters, how many moles solute are involved? What you would do, if you have your density triangle, you see that to solve for moles, you have to do molarity multiplied by volume. So you just do 4 multiplied by 12. The answer to that would be 48 moles. 48 moles involved for that question, because you look at your density triangle. You look at your density triangle, see if the crayon will work. I don't know why it's not working for me, but you would look at your density triangle, and then that would allow you to see that you just do molarity multiplied by volume. For the second one, given a solution with a molarity of 9.3 and a volume of 1,800 milliliters, how many moles are involved? So same thing, you have to do molarity multiplied by volume, but you see here that you have milliliters. So how are you going to solve if you have milliliters? Well, you have to convert to liters, and all you do to convert from milliliters to liters is divide by 1,000. So I do 1,800 divided by 1,000 gives me 1.8. So then I would do 9.3 because that's my molarity multiplied by 1.8 because that's my liters. And I find out I have 16.7 moles involved. 16.7 moles involved in that question. And my last one that I look at here, given 12 moles of solute and a molarity of 12.1, how many liters of solution am I dealing with? So if you have your density triangle, you see to solve for liters, you have to do moles divided by molarity. So you would do 12 divided by 12.1, and you end up with 0.99 liters. 0.99 liters involved. So Draw the density triangle. That is what is going to end up being most helpful for you, because then you can see every single time how to solve the question. If you didn't draw that, and I can't get the pen to work, it looks something like this. You have molarity in one corner, moles on top, and liters in the other corner, and then whatever you're solving for, you just cover up, and it shows you how to solve it. So if you're solving for moles, you would do molarity multiplied by liters. If you're solving for molarity, you do moles divided by liters. And if you're solving for liters, you do moles divided by molarity. And then the only other thing is you got to note if you need to convert from milliliters to liters. So there's going to be a lot of molarity questions on there. If you have questions about molarity, go back, watch the molarity video where I do a lot more examples, and you can watch those examples and feel successful. Hopefully you watched this, took good notes, and you will do well on the exam. Good luck and farewell.